Okay, I'm going to show you how to find the arc length given the radius and central angle of a circle. And we're going to keep all these in degrees mode. We're not using radians for these examples, strictly degrees. All right, so first of all, there's three main things with arc length that we need to consider. And those are the central angle, which is the angle formed between the two radii of the circle, the radius, the length of the radius of the circle, and of course the arc length. That's what we're figuring out. Okay, so the arc length is dependent upon those two things. How long the arc length is depends on the central angle and the radius. Okay, one thing is the arc length is always going to be a fraction of the total what of the circle, total circumference. All right, the circumference is all the way around the circle. The perimeter of the circle is the circumference, and that has a formula. Okay, that formula is for circumference 2 times pi times radius. So our arc length is always going to be a fraction of this. All right, and that fraction is going to be the central angle out of 360. That's why a quarter circle is a quarter circle, because 90 out of 360 is 1/4. So we can come up with a formula for arc length that depends on the circumference. And it looks like this. The arc length is a fraction out of 360, the fraction is the central angle out of 360 times the circumference. And if we want to write, the circumference of a circle can also be pi times diameter. So we may see it like this sometimes as well. And I can simplify this formula, but I'm not going to. All right, we're going to look at three things. First one, finding the arc length, okay, given the radius and the central angle. Okay, first example here. I want to find the arc length here. I'm given my radius is 8 centimeters, and my central angle is 65. No, it isn't 65. Okay, my central angle is between my two radii that intersects my arc length here. So if that's 65, this will be, that's right, 115. Okay, so we've got 115 degrees. And here I simply just use my arc length formula. My arc length is going to be 115 out of 360 times the circumference of that circle, times 2 times pi times my radius. Okay, 8. And I can enter this on my calculator and get a value for the length of the arc there. Okay, so to 2 decimal places, I'd get 16.06 centimeters for that bit right there. Okay, now let's look at an example where we want to find out either the radius or the central angle. And we can use the formula here to figure that out. Okay, check this out. I want to find the radius, given the arc length, 17 centimeters, and the central angle is 82. All right, now I could plug these values into my formula and solve for the radius. Okay, that's okay. But what I'm going to do is I'm going to take this formula, write it down, and rearrange it to get r by itself, because that's what I want. So I'm going to take this formula, and since I'm solving for r, I'm going to leave that bit of the equation on the left-hand side. So I'm going to write it out. Okay, so stick with me here. I want to get r by itself. I want to have r equals my formula. So to do that, I'm going to multiply the arc length by 360 to get rid of that fraction. And I get theta, the angle, whatever that is, well, it's 82, but times 2 pi r equals s times 360, which is just 360 times s. Now I want to get r by itself, and these are all connected by multiplying. So to unconnect them by multiplying, I'm going to divide it. So I'm going to say 360 times my arc length divided by the angle, and 2, and pi will give me that radius. Now when we do this on the calculator, we might want to put some brackets around here like that so we don't make any mistakes. Okay, so now it's just a simple case of substituting the values in. This is 360 times my arc length, 17, divided by the central angle, 82, times 2, times pi. Okay, and the rest I can put on the calculator. Okay, 11.88. Now this way was done by rearranging the formula first. You know, you can't just enter them in here and solve for r. A little bit trickier, but it's doable. Okay, one more example. We should be good after this. Okay, this one, of course, is going to be the third thing. Find the central angle, this guy, given the arc length, 14, and the radius, given the radius, which is 11. Now I'm going to do the same thing I did here. I'm going to write my formula and get theta, the angle by itself. So I'm going to write it down just like I did here and try to get this by itself. All right? Let's do it. Okay, this should look familiar. I'm going to multiply the other side by 360, and I get pi times 2 pi, no, not pi, that's theta, times 2 pi r equals 360 times my arc length. Now what am I going to do? I want theta by itself, so I'm going to divide by 2 pi r, and I'll get it. So my central angle equals 360 times my arc length divided by 2 times pi times my radius. Put those guys in brackets if I'm doing it on the calculator, and I'm good to go. So it's brackets 360 times my arc length of 14 divided by 2 times pi times, what was my radius, 11. Done. Well, I'm not done, but I'm done with all the hard work. And now I'll find my central angle via the calculator. What do you get? I get 72.92 something, so I'll just give it to a whole number, 73 degrees to 2 significant figures. How does that look? Okay, so that's it for now. You can try some more practice on your own. Good luck.